Okay, so I'm gonna do the 9/11 tragedy pager intercepts analysis. Come over here. We can see that it is a 50 megabyte text file. And yeah, it's just a text file, which you can download from here. Put the link in the description. So it's from 3 a.m. September 11th. That's actually a typo. It says 2011. So it's from 3 a.m. September 11th, 2001 to 3 a.m. Wait, 3 a.m. Sorry, I guess it would be September 12th. Because it's a 24-hour period. Yeah, so there's lots of ways to do this, this is pretty complicated. Like this is definitely not a new task, especially for kind of a new people. What we've got here is basically this is like a log file. From like a server log. So you've got what I think is basically 1, 2, 3, 4, 5, basically six fields or 6 columns. So you've got the date time attribute here, which is good because that's already a format that it's a standard datetime format. This is from the, like, I did a bit of research on pagers, which aren't really used anymore, obviously. Metro call, so Arch, SkyTel, there's 1, 2, 3, there's like 4 carriers. These are carriers. These are like the companies providing the pager service at that time. These here, this is what I think is one of the more, as of right now, from what I know, the interesting part of the data is I believe these are unique. These are like user IDs of some kind, whether it's I'm pretty sure, and we'll go into that later, but I'm pretty sure these are the unique pager IDs. And then there's another row of BC, like basically alphanumeric characters. Just a single one. Because here it's a 3, here it's a C, right? And then you can also see here, also for this column here, then there's a few of them that have curly brackets as opposed to square brackets. And these are all important details, and you'll see why later, if you're kind of new to this when we're writing our regular expressions. This is alpha. This is, I believe these are like frequencies. 2400 and 1200 are frequency bands for I forget the name of the type of pager. I think it's like POG. It's POG something. And you can see that, and there's a few, like there's alpha, like this alpha alpha, and then we have st space num. And then you've got 1200, 2400. So I think these are like bandwidth frequencies or something to do with the frequency of like transferring data between towers and the pagers. And then finally you have the message. So you basically have 1, 2, 3, 4, 5, 6. At least that's kind of what I've gathered so far. And then the messages are kind of a mishmash of sort of server, server messages, and then actual, text pager messages. So you've got like a SQL server. Yeah, there's all kinds of stuff in here. So what we're gonna do is, well, we're gonna do a lot of stuff, but we'll get into that. So the first thing you're gonna do is load up the text file here. Okay, so right off the bat, so the first thing we have to do is process this. We have to clean it up, cut it up, make it we have to perform pre-processing and to make it usable. So when we read this in here, let's just read this in and then you'll see. Okay, so yeah, I had a bit of a issue there, but yeah, as you can see that, so we're using the standard read CSV function, the famous read CSV, and then so because it's a text file, we read it as header equals none because there is no header, right? This file line 1. Pandas reads this as all just one giant column. So it's a data frame with one column. Now, just so you know, I did remove a column or a comma. I don't know, I think it was like here, it was like this with a comma, because the default setting for when Pandas reads it in for the separator, this is the default for separator. You could change that, but it works pretty good. But so I think it was here, and I just took that out, and then it was only one column. Okay. So to get this to read properly, so if you don't have the error bad lines, it won't even work at all. So if you put that in, it'll read, but then but it'll only give you, as you can see, 375,000 rows, and this is like 450 or something, so it's like a significant, it's like 20% of the file won't be read. So what you got to do is this here. And the reason for this is because of all the special characters in the file, right? You've got, I think I read like on the forum, it was like because of double quotes. And I mean, like, it's just like everything. It's a tactical nightmare, as some would call it. So that's why. So we use DT tag, which is I can't remember. Yeah, whatever. But it's T, which is I forget, but and then we're gonna use CSV quote none. Which instructs writer object to never quote fields. When the current delimiter occurs in output data, it's preceded by the current escape character. If escape char is not set, the writer will raise error if any characters that require escaping are encountered. Instructs reader to perform no special processing of quotes. Yeah, so it's for this basically tells Pandas to just ignore all this bullshit. So yeah. Okay, so when we do this now, you can see that now we get 448 at 450,000 pages. Okay. So now what I did was this file's not that big, but just as a demonstration, just kind of a technique I don't see used very often. It's called a converter, which there's really not a whole lot of documentation about it, but if you go to like for read CSV, dicta functions for converting values in certain column schemes can either be integers or column values. So this is useful for when you have a large file and you know that there's certain things that you want to do no matter what, like usually like basic stuff. So this is good for data formatting because you can you can process the file as it's being read into memory, as opposed to reading it all in the memory and then doing the processing after, you know, after your file's loaded. It's much more computationally efficient to do it this way. So one of the things I like to do is double spaces to strip all of that out. So like here you can see that this is a double space, and it makes so for our regex to be it provides more accuracy, which is obviously crucial in this type of messy pile of crap. So yeah, so what we do, so the way you use converters is you write a function that takes in, it's on a per column basis, right? Dicta certain columns. So you write a function and then you put it into a dictionary and then assign it to the column. So because we used header equals none, it gets read in as 0. And then there's no reason to put, like, you don't need to put brackets there. It doesn't work if you do. And then you just use 0 because there's only one column. In Python, index is from 0. And yeah. So save that, run it again. Yeah, and you can see that it works. It does work. It strips out the extra spaces. So I tested this already. Some other things you could do would be like to normalize it is like let me make a note here actually. Check character encoding, a library called chardet. And normalize encoding with uni decode. And that's a whole other thing. But we haven't had any Unicode, encoding errors that I've seen, so I'm going to assume it's UTF-8. But yeah, you could do that too. Okay, so now what we're going to do is there isn't really like a it's pretty tough. My strategy is to basically just get all the stuff that's easy, right? So basically, like, we know it's date time, so we're gonna extract that into a new data frame. We're gonna take the carrier, that one, so new data frame, this one, 2. So basically 1, 2, 3, 4, 5. So we're gonna make 5 new columns because we know that those 5 features are on 99% of the rows here. Okay? So there's almost like 2 processes. It's get all the stuff that's easy, and then the text, the actual message, which is a whole other thing. So what we're gonna do is make a new data frame, and we're going to use the str.extract. This is a Pandas function, string manipulation function. And here the documentation, but yeah, you'll see. So the first thing we're gonna do here is so if we get rid of expand equals false, oh shoot, so the first so to get the date out, right, first date timestamp, right, regex, right, so it is, so you do R for so that it reads the raw string, and that the extract function recognizes it as regex. Make a capture group. And then you use D for digit. And then you could do D for, right, and this would be 4 digits, right? And then you could do like space DD or dash DD, and then you do space, right, backslash S is space, backslash D 2 colon backslash D 2 backslash D. Right, like, sorry. So this is like the noob way. If you do it like this, people think you don't know what you're doing. So, better way is to do it like this. It's much more readable. Regex is absolutely terrible for reading. Right, so it's just saying we want 4 digits, we went with a dash, and we want 2 digits, a space, right, because that's what we have here is a space, right, and then we want we want 2 digits, colon, 2 digits, okay, it's pretty straightforward. So, yeah, just let me delete that. Okay, there's our new column. All right. So, company. So, this is a bit more tricky. I mean, I just scrolled through it and basically, for right now, I mean, because it's kind of, I don't know, like, yeah, I just scrolled through it and read all the names that I could find, because you can't just say like, yeah, I don't know of any other way to do it at this point. So we got a capture group, right, and then the bar is or, so we were basically saying we want SkyTel or Arch or MetroCall or WebLink B. Throw that in the company, okay, so these are all capture groups. And these are specific enough on their own that we don't need any word boundaries or, you know, extra characters at the end to sort of make sure that it's picking this up, because they're pretty specific already. And then device ID, so yeah, this one here is sure, let me take this, put this up here. Okay. So okay. So company, like I said before, It seems to be a digit 0, 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, I just said it's, I think, between 7 and 9 characters. 3, 6, 7. So I just said a digit, 7 or more characters, enclosed in square brackets or curly brackets. Okay, and then you need this backslash here to escape. Whoops. To escape the backslash, okay? And that works, as you'll see. It's good enough. And with Regex, sometimes you're just trying to do good enough. Okay, so let's run that. Okay, as you can see, works pretty good. And then, if you look, it's capturing, like, I mean, date and time and company got everything, right? And then device ID 230, so it's like 174 or something, which could be our fault, my fault, for, yeah, like, so this is not null, so that means that there's 170 null values in there. But anyways, we'll move on. I'm not going to worry about that right now. Alphanumeric. So here we've got, because this is more vague, we're just saying we want one letter or one number. I included spaces on the ends because it wasn't to sort of specify that it's this one here. Okay, and again we're saying we'll want a capture group with one letter, one letter of the alphabet, A to Z, or one number 0 to 9. Okay. And then baud is alpha. Yeah. And then again I specified that specifically. And because I have again another vague capture group, I include the spaces on the ends so that it knows that it's just going to be, like, for instance, here at the top, I'll show you. Like here, right? 4 digits, which is, these are actually the exact baud frequencies, so that's why it leads me to believe these are frequencies. Okay, so yeah. Okay, so now what are we left with? Okay. So now we've got, yeah, so that's pretty much it. Now we just have the message. So how do we, I'm not interested in writing, I don't even know where to begin to write regex to extract whatever these messages are. So what we're going to do is, with this stuff, you can either, remember, there's kind of 2 ways to think about using regex for this stuff. You can either, you have a piece of data, you can take stuff away from it, you can extract stuff from it to get in the stuff that you want out, or you can extract the stuff that you don't want out, and then whatever you're left with, is what you want. So that's what I did. So then everything that we just extracted here, we're just going to use the same regex to replace them with empty strings. And then and then I'll show you that here. See that, yeah, and this is pretty accurate. Like it's not, yeah, it works pretty good. So then what we do is we just assign df0 after everything's been extracted out to df1 message, and then I sent that to a CSV. I already wrote this there, so I'm not going to do that, but yeah. Okay, so, and then what you'll be left with is a nicely formatted CSV. Okay, and I'll go into that another time.